I
I think it's right, but
yeah, I've done it before.
Okay,
So ask her.
let's see if I'm better this year.
Miss, you're always good at explaining.
Thank you. But this seems to be one of those topics. Polar coordinates, we'll call this a fight, versus rectangular coordinates.
What? What's the problem?
Ah, excellent question. Okay.
no sé.
When you've noticed that there's the metric system and there's the
U.S.
English
system. Yeah.
You've noticed that you can give temperature in Fahrenheit, Celsius, Kelvin, right? There's lots of ways of saying the same thing. For a girl, you can say that this color is salmon.
On this
Like
again.
salmon. For a guy, it's pink. If they get it,
That's like what we talked
otherwise
about,
it's red in their heads. We call it indigo, they call it blue. Okay? That sort of thing.
Oh.
But in itself, there's different ways of saying the same thing. Do you agree? When you say that you want to get to a specific place, there's two ways you can do it. One is by using rectangular coordinates. I'll show you what it looks like. I'll show you what the book does, and I'll show you what the rest of the world does, okay? Rectangular coordinates for the book are like this. 2 right plus 4 up. The rest of the world uses 2I with a little hat plus 4J with a little hat. I will explain what that means. What does this mean? If I have a rectangular coordinate system, or coordinate system, you know that this is y and this is x, right? In general, correct? You know
Thank you.
that this is positive, positive, negative, negative, right?
Yes.
Negative, negative, positive, positive. So what this is telling you is you are going to go 2 to the right, meaning 1, 2 this way first, and then you're going to end here, and then you're going to go 4 up. Okay? This is 2, this is 4, and you're going to end up here. If you are an airplane, you will fly from the airport to that point that they told you. Okay? Does that make sense? Okay. Let's say that I tell you to go minus 2r minus 4u. Even though this is right enough, I'm going to go minus 2 to the right. If it's minus, you know you have to go the other way, right? So it would be minus 2 here.
And 4 down.
And 4 down. That's sort of clear now, right? So you would end up, first you go here, then you go here. So you end up in this point, and since you were at the airport, okay?
Wait, how do you go down from the number?
The arrows that I draw are called vectors. Okay? These arrows, and they have to have an arrow. Why? Because they show direction. They show math. Did anybody watch? And if we don't finish today, this is not for tomorrow, so relax.
Hey.
Did you watch Despicable Me?
Yeah.
Oh yeah.
Do you remember that the guy who shoots squid from his thing?
Oh yeah, the
Yeah,
skinny
with
guy.
the
What's
Orange
his
guy. Vector.
And do you remember why he was called Vector? Because he had magnitude and direction. Do you remember when he did that?
Oh yeah.
This is a vector. It's got magnitude because it's got a size, and it's got direction. This
Makes
direction
sense.
is different than this direction. They have the same size, right? Because they're both 4 and 2, but they have different directions. They have opposite directions, okay? Now, so far so good? Okay. So you understand the R and the U? That's what you'll see in the book. What I want you to do is not the R and the U, but use the international system, which is the I and the J. I will explain what the I and the J is. Have you noticed that we have an X and a Y, and they are consecutive in the alphabet? So are I and J. The little hat tells you that you're talking about vectors. Why? Because it's the tip of an arrow, just like the tip of an arrow, okay? Why I and J? Because I represents what you're doing in X.
No,
J represents what you're doing in Y.
it also says
And J.
it uses a K.
When you're doing Z, when you're doing 3 dimensions.
Okay. Three.
And how's the K with the R?
The X wants to be like an airplane.
Can we do 4 dimensions?
Okay with the hat. Okay?
Oh,
Because the hat tells you it's the tip of a vector.
it looks exactly like French.
Okay. So far so good?
I don't know.
Which one you use is up to you. If you use I and J, you will make your life easier because you will make it, get used to what you will see in college. Okay?
Wow.
This is what you use in physics. Okay? Have you understood rectangular coordinates? Now, let me go to polar coordinates. It's exactly the same thing, but expressed differently. I have the same exact thing, and I'm going to do, we had it here, right? It was here, this was a 2, no, what? A key. There was a 2 here, and then a 2 here, 4 here, right?
Mm-hmm.
4 and 2. And we had this vector going this way. Okay. Do you remember that when you have a coordinate system like this, it goes, you start counting the angles this way. Do you remember that?
Yeah.
Yeah? Did we see that yet? No. Okay. This is your 0. This is your 180. This is obviously your 90, and this is your 270. Okay? Is that clear? Fine.
Yeah.
So, I'm going to stay on this side. And I'm going to say that if you are here, this is going to be 45 degrees, for example. Okay? Is that clear? So, and it's always with respect to x. You could do it with respect to y too, but let's do it with respect to x and this one. Okay? This one is going to have an angle, and this one's going to have a magnitude. The magnitude, have you noticed that it's a triangle that you recognize?
Yeah,
Sine, cosine.
It's a right triangle. You see that. Keep that in mind, we'll use that later. For now, we know that this is a hypotenuse, right? And it's got a size. And this has an angle with respect to this. When you are flying a plane, or when you go, have you been in the States?
Yeah.
No. In the States, usually, or have you been to Antigua? Have you seen the signs for the streets?
Yeah.
They say Primera Avenida Norte, Primera Avenida Sur. And it's the same one, but Sur goes that way and Norte goes this way. Okay. O Oriente Poniente, East West. If they tell you that you're going to go I'm going to take this away. I'm going to go 30 degrees. This would be northeast, right? Would you agree?
Yeah.
Instead of writing it this way, I would write it like this. 4 degrees for whatever, 30 degrees. This I know means my hypotenuse is 4, my vector is 4, this is 4. Actually, I'm not going to use a 4, I'm going to use a 5.
Why?
You'll see why.
So it's easier to divide?
Why?
And it says 30 degrees. If it says 30 degrees, I know that I have to start here, and I start counting 30 degrees. So I end up in this point. Okay? And then I draw this. Okay? Let me do another one, because I started backwards.
Miss, read a question from the book so we know
No,
how
not yet.
If it says
Not yet. Trust me.
If it
I've
says
done this 25 years. Trust me. No.
25
Hold
years.
on. Let's say I give you 1075. What do?
The line will move to 75 degrees.
The first thing you put is the angle. The angle would start counting here. Where would 75 degrees be? Around here, right? More or less?
Yeah.
75 degrees. How big is it?
10.
10. And you put your vector. That's how you draw this. Okay? Now, do you, so far so good?
Yes.
Yes?
How do means how like why 10? Like how do you know it's
Why not?
Because it tells you.
oh.
Just tells you.
Oh that's the
That's a given.
But that thing is already gonna be drawn, right?
I'm gonna, no, you draw this. This is gonna be given.
oh okay.
Let me do another one. How about minus, no, not minuses yet. 3, 120.
Then you'll go.
That'll
You
be like
go 120, this is 90,
Oh.
this is 30, right?
and then you put 3.
How much would be left here if this is 120?
Why the other way?
60, yeah.
Because it's easier if you always do it with respect to the x.
Okay.
Okay? Is that clear?
Can we just do that at 100?
You can do the 120, but you have to do it per quadrant. You'll see why. But for now, let's do it differently. Let's do 30.
This, where do you write the 3?
It would be 30, right? First, and the 3. Notice that the size of the arrow doesn't matter. It's just a representation. It's just a sketch to tell you where it is. So far, so good? Yeah?
Miss,
Yes.
so if it's more than 100, it's that side?
Yes.
And if
But
it's
I
less-
think we haven't gotten there yet.
More than 90.
Oh, you have. Yes, you have. You do. So let's do one that way. 230.
Hold on.
Wait, over 90 or over 100 has to be.
Over nothing.
What are you talking about?
Oh yeah, okay, look. This is how you count. You start going here. This is 90. This is 180. And you have more than 180. So it's going to be 50 here. Because it's all of this, right?
Yeah.
But you are only going to write here. How much would this be?
Like 200 to
50.
50.
3.
Who said 50?
I did.
50.
15.
Because this is, it's assumed. This is 180.
Mm-hmm.
And you have 230. How much are you missing? 50. Yeah? No. Let's do another one.
Yeah, I
Ah,
got it.
yeah,
I got it.
I
I
got
got
it,
it.
I got it.
I got it.
310.
Wait.
180,
Yes.
190.
310 down there.
Where would it be?
There.
It would be here,
One would be
right?
130.
But instead of writing, it would be 270. And you, how much are you understand that this one here is 270. This one would be 40 more, right?
Yeah.
40 more.
But instead of putting it here, you're going to put it here. So how much would that be?
40. Oh,
60.
50.
50. Oh, because 50 plus 40 is 90.
Because these are all 90. Okay?
It's almost
Why here? Because I need you to, for practical purposes, learn to put it here.
Oh, so
Okay, fine. You can put it here if you want. Let's put it here. 40. Right? Because it's 270 plus the 40 to make 310. Is that clear?
Mm-hmm.
Yes? So far, so good?
Yes.
You understand that these are two different ways to get to the same point from the airport. You always start, this is the airport, this is always the beginning, and the tip of the arrow is always where you're supposed to be. And there's two ways of getting there. You either go directly because you know the angle and the size, or they tell you first go to the right and then go up. Right? So far, so good? What do you notice that is similar between this system and that system? They have one thing in common.
The arrows.
The arrows are in common to both of them. So I will teach you how to go from this system to that system and vice versa. Okay? How? Because the arrows for both of them are hypotenuses in both cases. And in both cases, you can get right triangles out of them. Hence, hypotenuse. Right? If they're not right triangles, they can't be hypotenuse. So you have a right triangle here and one here. And you have a right triangle here also. You move the x and the y, right? If I put it here, even if they only give me the hypotenuse, and they tell me that this is 35 degrees, and I know that this is 12,
You'll always
excellent.
get 90
Do you
degrees.
remember when you learned sine, cosine, and tangent?
Yes.
You were like, what the hell is this for? It's for this. And it's not, this is something that people who fly airplanes use. People who navigate
Chips.
GPS. GPS is based on this.
Ways.
Ways, everything that we use now can be done because you have coordinates, you have angles, you have vectors, you have rectangular coordinates and polar coordinates. Without this, satellites, useless. Okay? That's what this is for. And you will learn how to go from one system to another. How many minutes do I have? Two? Bye. So, for now, we'll leave it at this. Tomorrow, are there any questions here?
So this is part 1.
This is part 1.
Okay, well.
Okay.
I mean, Sophie.
We'll do part 2 tomorrow.
What